Okay, so this is week 4, lecture 2. We are finally at that particular stage of the course where we are going to probably discuss one of the most popular programming paradigm, the for loop. So what we already know so far, especially from the previous lecture, that in the do while loop, the condition is put at the end of the loop, right? So basically just after the body of the loop. So this means that the loop will run at least once because the condition, even if it is false, it will be evaluated at the end. In the while loop, the condition is put at the beginning. So even before the body of the loop can be executed, the condition will be evaluated, and if it turns out to be false, the body is never executed at all, right? Now, in addition, we also realize that there are two more types of statements that will be there if we are trying to write a loop. There will be certain statements where we will try to set certain initial values for important variables. So these important variables are basically the variables which are being used heavily inside my loop's body. Basically, my loop's body actually depends on these variables, and then within the loop, I also have to write certain statements which actually updates the values of these variables. Otherwise, the condition that I have, that will probably never be false because my variables will have the same value all the time. So I do need certain statements which keep on changing the values of my variables over which my condition has been written. So now in the while and do while loops, there were actually no place, no specific designated place or slot for putting these other two types of statements, right? But no, in the for loop, which is basically a very common loop in almost all the programming languages, there are actually slots, to provide the other two types of statements as well, the initialization statements and the update statements. And by the way, the syntax that we would discuss here is exactly the same for C++ and Java as well. I'm not sure about C sharp, but there is a good chance that it will probably be the same in C sharp as well. So basically this syntax that you are going to see now is a very common syntax for writing for loops. So this is the syntax. You essentially have the same things, the statements before the loop and statements after the loop. Now you write this for is a keyword, uh, similar to while or to while. Then what happens, you have these three slots here, right, within the parenthesis. The first slot is initialization. So you can do the initialization of certain variables here. The typical statements that you will see here are assignment statements, I equal to 0 kind of statements. So this is like x equal to y kind of thing. um, the second part is condition. So in the condition you put the same condition as in that we've been putting in the do while and while loop. So essentially this is the condition to stay inside the loop, right? So basically as long as this condition is true, you'll keep executing the control will keep executing the body of the loop, and the moment this condition becomes false, the control will jump out and then it will come here. And then you also have a slot to put the updates, right? So for example, if your loop is using I as a important variable to execute the statements inside the loop, you can do something which actually updates the value of I here, something like I equals I plus 1, or I equals I plus 2. Again, every time I say equals and plus, do remember that it doesn't mean that the values have to be only updated by a in a certain fashion, right? So you can always use any kind of update statements, okay? So you can, it's not necessary that the loop variables are only incremented. They can be decremented. You can multiply them, you can divide them, basically any possible way you can change them. But the idea is that you keep updating them. Otherwise, if the condition is based on their values and their values do not change, then this condition kind of becomes true always, and then this becomes a kind of infinite loop. So in the for loop you do have a slot here, so you can actually put your update statements here. So you can see that this is a very compact way of writing a loop, right? So all that you require for writing a simple loop, the for loop basically provides you at one position. and this is why it is one of the most common loops and most popular loops that people use. Now, in order to understand how the flow moves through in a for loop, because you can see that it's already a bit compact, but at the same time a bit complicated as well. So this is exactly what happens after the statements before the loop are executed. So as soon as the controller sees a for statement, the first thing it does, it actually runs the initialization related initialization related statements. So you can, by the way, have more than one initialization statements here, separated by a comma. So the initialization statements are executed. Then the next thing it does, it evaluates if the condition is true or not. So this is similar to your while loop. So the condition is evaluated before you enter the loop. Then after that, the update is not executed right after that. So basically it starts with initialization, then the condition is evaluated. If it is true, the statements within the loop are executed. Then once this all these statements are executed, the control flows back to this point where whatever update statements, again you can have more than one update statements here, separated by a comma, and then whatever update statements are there, those updates will be performed, and then again you'll go back to the same place, right? So now this is how the loop actually works, right? So now again, the condition is checked. If it is true, you again enter the the loop. Otherwise, if it is false, you basically go out of the loop. So this is one way to understand it, that this is how the loop actually works. So you come from here, this is the first thing that gets executed, and this is only getting executed once. This is the idea. Okay, the initialization part only executes once. Then you come here, this is executed. Then you move down, the whole of the loop's body is executed. Then you actually go back like this. Okay, you go back to this point. This instruction is executed. Then you come here again. If the condition is still true, the cycle gets repeated like this. Okay, so you keep on moving here until this, you reach here and the condition is false, in which case you basically make a move out of the loop. So this is how the actual flow works in a for loop. So when exactly should we try to use the for loop? Now, similar to the while and do while loop, the for loop too can be used for any scenarios. You may have to write it in a certain fashion, but all these loops are basically equivalent. You can use any loop at any point of time. So if you already have a personal favorite, in theory, you can use the same loop at every junction that you have to put a loop, right? So at every place we want to put a loop, you can use any of the three. However, the usual place where we use for loop is where we know precisely the number of times the loop is going to run. So one simple example where for loops are used most often are when we are trying to go through the elements of an array, right? So there we already know the size of the array, and we know that the loop must iterate through all the values in this array. So we might actually be assigning values to them or accessing them. So all you need is a loop that runs from the first index, that is 0, up to the last index, that is the size of the array, and totally the loop should run size of the array times. So in such cases where you already know beforehand that this loop must run, let us say, n times, there it is easy to formulate a for loop using a simple variable like I. So I'll just show you one example, the marks calculator tasks that we discussed last week. The for loop is a very good choice there, right? So this is what that that example look like, and this part we have already discussed. We discussed that we can actually rewrite this part in a more in a better fashion. We also saw the pseudocode for this part of the code. So now you can basically see something like this, that all these are equivalent. So this is the first version that we had. Then I said that you can replace it with a version like this. You start with a variable I, you assign it the value 0. 0 is the first value I want here, so I assign it the value 0, and then after each of these instruction gets executed, I increment the value of I by 1, I equal to I plus 1, and now you can see that these statements are exactly the same statements, right? I and all that is happening is that after each one of these getting executed, I am just incrementing I by 1. Now this is an equivalent for loop. So you can already see how compact this is with respect to these two. So essentially what is happening here is that you are using a variable I, and you want the variable, it is the same thing, and I equal to 0, I less than 5. So essentially this condition is true until I becomes 5. Okay, now here this is the difference, that here my value of I would remain 4 only, right? Because I'm starting with 0 and I'm not putting an I equal to I plus 1 here because I don't need to. But here what will happen is, as soon as I actually gets incremented by 1 because of this statement, so I plus plus, as of now, just understand it is equivalent to saying I equal to I plus 1. So what happens is, if you remember the flow in which the loop will work, so this statement will be executed first, then this is checked. For the first time I will be 0, so this condition is true. Now this statement is executed, and so this is another thing that you have to understand, that ideally I should put it into braces, right, similar to while and do while. But with for, if I have a single statement with the loop, I don't need to put the braces. So anyhow, so what is happening is, I start with I equal to 0, and the first time i's value is less than 5, so this statement is executed. You can see that this is exactly the same statement that it was here. Now what happens is, as I said, the loop's flow will then go back to the update point. It will update i's value by 1. As I said, this is I equal to I plus 1. It will recheck the condition. Now I has become still 0 plus 1 equals 1. It is still true, so it will go in here again. This process will continue till I equals 4. The statement with I equals 4 is executed. After that, when the update happens again, I will become 5. This condition becomes false, and you will come out of the loop. So this is the idea. um, in the modern compilers, you are allowed to do something like this. You can actually declare a new variable right here inside the for loop. Okay, as far as I remember, in the beginning, when C started, really, the first few versions, I guess, of C, this was illegal, right? Because as I have already told you, it was expected that you declare all the variables of your main at the beginning of the main itself. So this was illegal, but today's compilers will allow you to do this. Um, the only thing that you have to understand is that the scope of this variable I. So scope essentially is the place where a particular variable is visible. So essentially, um, the scope of this variable I that you declare uh, within the for loop is limited to this for loop. So you can use I within this for loop, but not after this. Okay, so the scope is essentially the visibility of a variable. So the visibility of I is just limited to this loop. If the statement that is next after this statement, the right next to the for, I is not visible there at all. So if you try to use i's value there, here, it will not work at all. So this is something that you have to understand, that if you declare a variable within the loop, it will only be accessible within the loop and not beyond. But so sometimes it might be a good idea to declare int I separately like this, and then simply start it with I equal to 0 instead of int I equal to 0. And this I have already told you, because I have a single statement, I am not having a braces here. So some more points about the for loop. The initialization part of a for loop is executed exactly once. This I told you. So this is when right after the previous statements were executed, the initialization is executed. That is only once. Now all three parts of the for loop can actually be an empty statement. So what is an empty statement? An empty statement in C is simply a semicolon. Okay, if you put simply a semicolon, nothing left on the left side of the semicolon, that is considered as an empty statement. Now what this means is that you can actually have something like this. Okay, so you can write uh, so I should not say all three parts. They are basically all three slots, right? So all three slots can have, can have nothing, to be honest. So essentially you can basically just put two empty empty statements, and so this slot is empty, this slot is empty, and this slot is empty. So these two semicolons are just segregating the three parts. So you can leave the three parts as empty. So what this means is, uh, if you leave the condition part as empty, then it means that it is evaluated to true by default. So this is equivalent to saying uh, semicolon 1 semicolon. Okay, so 1, as I've already told you, in C, 1 means true, and actually any non-zero value means true and 0 means false. So if you do not put anything here, it gets evaluated to true always. So this loop, if you write it like this, it essentially becomes an infinite loop, because there is no condition, it will always evaluate to true. So your control will keep on flowing within the loop, unless you have some other mechanism to break out of this loop and go to the next statement. So that mechanism, we will study in the next lecture. Okay, so that mechanism is very important in programming, because till now we have only seen loops where the break, the conditions are at the top or at the bottom, but you can also have these conditions in the middle of a loop as well. So if you want to put the condition in the middle of the loop, there is a specific mechanism to break out of the loop. We will study it in the next lecture. So this is one more example of for loop. We have already created the factorial program using while and do while. So for the sake of completeness, this is also this is just doing the same thing using for loops. I have two for loops here. The first one is basically equivalent of the do while loop in the previous lecture that we saw, and you can see that I am not using two slots here, right? I'm not using the initialization slot, I'm not using the update slot, I'm just using the condition slot here. And as I said, this is also possible that I can actually remove this as well, but then I'll need to put some mechanism here to break out of the loop. That, as I said, we'll discuss in the next lecture. And this is the compact loop, okay, where the actual factorial is being calculated. See that I have initialized I to 2, so that that factorial 0 problem that we were discussing, right, that I do not want this result asterisk equal to I statement getting executed when my num is 0. So that part I have already taken care of, that this loop will not run if num is 0 or 1, because this condition will become false in the first time itself. So there is an operator that you have seen there. I've written something like I plus plus. I simply told you that this is equivalent of writing I equal to I plus 1. But this operator is a very common operator that you will see, especially with for loops. And there is one more thing that I have told you till now, that in most cases we assume that the expressions are evaluated from left to right. There are certain exceptions I have told you. So this is one of the exceptions, by the way. Um, the plus plus operator is actually a unary operator. So you apply it with just one operand, and that operand, I should have written it here. The operand has to be a variable only. It cannot be a constant. Okay, it cannot be more than one variable, so it cannot be an expression either. It has to be just one and only one variable. That is the unary operator that plus plus operator will take, unary operand that plus plus operator will take. This has two avatars actually. There is the prefix plus plus. So for example, if you write something like this, plus plus I, this is the prefix plus plus, and the postfix plus plus, where you write something like I plus plus. So what I wrote there is I plus plus. I could have also written plus plus I in the same example that I showed you. So how to interpret this? The postfix plus plus, which basically appears after a variable, that is why it is called postfix. This can be interpreted as use the value of this particular variable, in this case I, and then increment it by 1. So this is the idea, that wherever you have put I plus plus, in that particular expression, in that particular context, the current value of I is used, and then I is incremented by 1. The prefix plus plus is incremented as is interpreted as increment the value of the variable by 1 first. Okay, so you have to increment it first and then use it. So I'll just give you an example in the next slide of what it means. Now, one thing that you have to understand is that postfix plus plus has a higher precedence than the prefix plus plus, and the associativity, the left to right, right to left things, the associativity of postfix plus plus is left to right, and this is basically what, and this is why this is most commonly used. This is that it makes more sense to us most of the time, and that of the prefix plus plus is right to left. Now, don't actually worry much about the associativity. We will discuss this issue when we have another operator which is at par when it comes to the precedences of these guys, these plus plus operators. That operator will basically be an operator that we will study once we have done a lesson on pointers. So for now, let us just leave the associativity doubt. So don't get too much worried about this left to right, right to left things. For now, just try to understand how they are used. So this is a very simple example. As long as you're using them in isolation. So what does isolation mean? That if you're using them like this, and this is how I used it in the for loop. If I simply write I plus plus and a semicolon, or plus plus y in a semicolon, basically as long as I do not use them in some kind of complex expression, they actually have the same meaning. So this is very important. And in most cases, at least at this level, in most cases, this is what you will use them for, just I plus plus or plus plus I. Usually the people who use them in expression, they already know the side effect of these. Okay, so for now, if you are new, simply pick either one of these two. Usually people pick this one. So whenever you are writing a for loop, just use this one. Okay, and if you do decide to use it in an expression, I won't recommend this at this stage, especially if you are a beginner. I won't recommend using them in expressions, but still, if you want to use them in expression, this is basically how it works. If the prefix plus plus, you use it something like this. Let us say the expression is written something like this: j equals k into plus plus I minus L. This is the expression. Then the equivalent of this expression is something like this. You first write I equal to I plus 1, and then you do j is equal to k into I minus 1. So this is the order, right? So essentially you are incrementing I first, and then you are using I's value to within the expression. So this is an equivalent expression of this. Similarly, if you use the postfix expression k asterisk I plus plus minus L, this is equivalent of saying j equals k into I minus 1. So whatever is the current value of I, use it in this expression, and then increment I by 1. So this is basically a very simple introduction. If you are using it in expressions, please be careful that you understand this. Otherwise, as I said, at this level it is fine to simply use them like this. Okay, they are just shortcuts for saying I equal to I plus 1. Okay, so this was your lecture on for loop. We are going to discuss this on Tuesday. Okay, thank you. Bye.